Okay, so lastly, we are going to do some miscellaneous exercises. So we are going to do some exercises which might be tricky for some students, but we are going to go through them. Okay, so firstly we have x cubed plus 2 divided by x squared minus 1. So as I said before, um, we are going to solve now. This is one type where wait, let's just see. Let's just check. Numerator's degree must be less. You see that the numerator's degree is 3. So the first condition is not fulfilled. When you see such, how do you proceed? So we have to know that this is the equivalent of having something like 2/8. When you have 2/8, well, as a maybe a lower C student, you just cancel 1/4. You have your answer like that. Well, if you have something like 2/9, okay, let's say 2/9, they want you to have the answer in decimal. How are you going to do? You are going to do the long division method and find the correct answer, because it cannot be simplified, because this one is smaller than the one under. That is the case here. So you are going to do 2 and 9. You are going to see that it is 4 times, then you have 8, 1, and blah 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 blah. So the thing is, you have to go through long division method to make this numerator to be the degree of the numerator to be smaller than the degree of the denominator. You have to use long division method. But it is not in all cases that you have to use long division method. I will show you in the next example in which case you can choose to not use long division method. You can choose to use your knowledge of mathematics, your tricky knowledge of mathematics. So here, when we use long division method, we have put the one that is under here, put the one that is on top here. So be very attentive here, please be very attentive, because some students always take much time to do it. If you don't understand on the first one, go back on the method again. It is not even difficult. It is just like you're dividing something normal. Okay, you have, when you see this, the thing you have to do, you have x cubed here. Here you have x squared. What do you multiply by x squared to have x cubed? So you look at the first thing, don't care about the next thing that behind it. First expression that you have is x squared. The first expression that you have here is x cubed. So what do you multiply by x squared to have x cubed? X. When you do x times x squared, you have x cubed, right? So you put your x here times. You put your x cubed. This subtraction. X times minus 1 is minus x. You do like that and you leave it. Now you come and subtract. You have already multiplied this times this and this times this. When you multiply the two, you leave it and you come and subtract here first before continuing division. So x cubed minus x is 0. People will be tempted to say 2 minus x. 2 minus x. 2 and x is not the same thing. So you can say 2 bananas and x potatoes. You cannot subtract them. 2 is 2. 2 is something that does not have x. X is something else. That's why you cannot subtract the 2. So what has x here? It is the same like x cubed. When you look at this very plus 0x squared plus 0x. When you check where you see that x cubed plus 2 is the same like x cubed plus 0x squared plus 0x plus 2. Because when you have x cubed, it means that there's something with x squared that is 0. There's something with x that is 0. And then before the 2. So you cannot subtract 2 by x only. You cannot subtract it because they are not the same terms. So here you can see that there is 0x squared. The value of x squared here is 0. When you have when you have something with x and in here, then you can subtract with this x. So x cubed minus x cubed is 0. 0x squared minus here 2 before reaching to minus x, you have minus 0x squared. Before reaching to minus x, they have still plus 0 because there's nothing after. You have just this and this as terms. So x cubed minus x cubed is 0. Minus 0x squared is still 0. So you have plus 0. Don't put 0x squared. It is 0. 0x squared minus 0x squared is 0, not 0x squared. It's just 0. So 0x minus minus x minus minus x. 0x is 0. 0 minus minus x is equal to what? You know that some 0 minus minus 1 is equals to minus 1. Yeah, come on, confuse me. So as I was saying, 0x squared, 0x squared minus 0x squared is 0. X 0x minus minus x is equals to what? 0x, we have to know that 0x here is the same like 0. So 0 minus minus x is equal to what? If you doubt the answer here, you can take your calculator and replace x maybe by 1. You give your calculator, it's there, you punch 0 minus minus 1. I always tell my students that when you see minus and minus, you just put this plus on it. You just put this cross, so I should put plus. That will be the same like 0 plus 1, which is equal to 1. In the same instance, you see 0 minus minus x. You just put this, join them. When you see minus minus, which are on the same, we are not separated by anything, you just put a plus in the middle, which is the same, it will be the same like plus x. Minus minus is the same like plus. So 0 plus x is x. And it is x, right? So I put x. And then 2 minus 0 is 2 of my x plus 2. Then I see that this cannot multiply this. The power here is already bigger than the power here. So I leave it like that. Yeah. So what will be my answer when I have the answer like this? If the power here was squared, I would have divided again. But now that the power here is no more squared. If the power here was squared, I would have divided because this power is the same like this power. But if I have an answer whose dividing, I stop dividing. Then I write my answer. My answer is going to be x whole number 3 x plus 2 on x squared plus 1. I write it like this. But you have to put this plus here. Yeah. So the answer is going to be x plus x squared x plus 2 all over x squared minus 1. So that will be the answer of this long division. When you divide this, you have this as answer. Okay, for those who have difficulties again in solving the long division method, I'm going to break it down for you. So We squared minus x cubed plus 2. Understand where? If you have this, if you are maybe a slow learner, what I'll advise you to do is you change this minus 1. You know that after x squared there is x. After x then there can be 1. It is x squared. This is the same like x squared plus 0x. Because if it starts with x squared, there is supposed to be a value of x. In this case, it is 0. Because there's no x here, so it's 0x plus 1. Minus 1, I mean. Minus 1. You come and, since it is x, then you put plus 0x squared plus 0x before the plus 2. Some people might say, yeah, it is longer, so it is more difficult. No, no, no. If you keep it because you don't know where to place what. Okay, so when you have it like this, the first thing you do, look at this first term. This first term here is x cubed. This first term here is x squared. By x squared to have x cubed. What do you multiply by x squared to have this x cubed? To find it, you just x cubed divided by x squared is equal to 1. Is equal to x. X cubed divided by x squared is equal to x. It means when you multiply x by x squared, you will have x cubed. You find that value, multiply by this, you have this because later when you have to subtract, you want to have 0 here. It is x cubed. I put my minus plus 0x, but it's 0x squared. X times minus 1 is minus x. I don't have any value here, I can put plus 0. I can replace it by 0. So, when I subtract, I have x cubed minus x, it is 0. That's why I was looking for a value of x, for a value that when I multiply by x squared, I'll have immediately x cubed because I wonder when I subtract, it gives me 0 at the first point because I want to eliminate the high value which is x cubed. So I have 0 here. X squared, 0x squared minus 0x squared is equals to 0. 0x minus minus x is 0x minus minus x. It is the same like 0x is 0 minus minus x. Substitute the x by 1 and you see 0 minus minus 1 is the same like 0 plus 1. If you don't know, punch in your calculator. You have a 0 plus 1 which is equal to 1. The same here, 0 plus x is equal to x. 0x minus minus x is equal to x. 0 minus minus x equals to x. So you have 0 plus x. 2 minus 0 plus 2. When you have your 2, you're done. So here, to know whether you have to continue, you can see the power here is 1. The power of x here is 1. The power of x here is 2. This power here is already bigger than the power here. You can see this power here is already bigger than the power here. We needed it to be bigger. So if I had square here, if I had this square here, I would have continued dividing. I would have said times 1 again. I mean plus 1. Plus 1 again because when I multiply 1, I have 1 times this thing, I have x squared again. In 1 times 0, I have 0, then 1 times. But this power here is already 1. So I don't need to multiply anything. The power here is already smaller than the power here. So I leave it like that. That is why my answer is going to be x plus this one, x plus 2 on this one. You don't write produce 0, you write it as it was here. Write it as x squared minus 1. So I hope at this point you have understood how I did the long division method. I think I explained it really well there. Okay, so when you have this That's why I solve miscellaneous questions. You have questions like that which are a little bit tricky. You have to know when to do the long division and how to do the long division method. Those questions they can easily give it for 5-6 marks. So when you have this like this equation becomes this. This is your new equation. You have x is always in partial fraction. You can represent this one in partial fraction. This one has been done before. So to represent this in partial fraction, you have x plus 2 on x squared minus 1. Here you can see this is an identity, a quadratic identity. It's the same like x plus 2 all over x squared minus 1 is difference of two squares, which is x plus 1. Difference of two squares, you have to know that if you have x squared minus a squared, it's the same like x plus a. Okay, this is the law of difference of two squares. Difference of two squares means it's a square minus a square. That's difference of two squares. You have x and x again minus a to the second square. A is the square root of the second value. In this case, difference of two squares. Square root of one square is 1. So you have x plus 1 and x minus 1. So here we can see that it becomes very easy. So when you put it in a recognizable form like this, you solve it easily. You are very happy to solve it. So to solve this thing, let me put it here. I have x plus 2 on x plus 1 into x minus 1 to solve this. I put it in my partial fraction. I ask myself the questions first. The numerator's degree must be less than the denominator. Is it less? The degree here is 1, the degree down here is 2. You have x and x, it's 2, it is less. So I can proceed in solving. The denominator must be factorized. You can see here that it is factorized. Here, factorized. Fraction form, we all know it is a on x plus 1 plus b on x minus 1. So here, as it is in miscellaneous exercises, we'll try to be, I'll give you some tips in solving. So here you can use what they call the cover-up method. Very simple method which can be used just for linear factors. So the cover-up method goes like this. Here you have a on x plus 1. You don't even solve. You here replace, okay, x plus 1. What value of x will you put here to have 0? X plus 1 is equal to 0. X will be equal to minus 1. So you have your minus 1 everywhere else. So if I put minus 1 here, I have minus 1 plus 2. I have minus 1. Minus 1 plus 2 is 1 divided by, I don't consider this part, that's what I cover up. I cover up this part. Then I put my minus 1. Minus 1 minus 2. Minus 1 minus 1 is minus 2. That's my value of a. If you check it using all of the methods that I've been doing, you see the value of a is minus half. You can check it yourself and see. B, using the cover-up method. B, a value of x, and when you put here, you have 0. You have x minus 1 is equal to 0. X will be 1. So the value of b will be 1. That value will be 1. So you cover this second one, x minus 1, you cover it here. And you replace your value of 1 on this equation. You have 1 plus 2 is 3. Divided by, when you replace your 1 here, 1 plus 1 is 2. So this is your value of a, this is your value of b. Using the cover-up method, you know that this is equal to, which implies x plus 2 on x plus 1 into x minus 1 is equal to a, which is negative half, negative 1 on 2 into, plus b, which is 3 on 2, 3 on 2 into x minus 1. Can you get answer like this? But as we said before, we don't always like minus to come first. So we put this one first, then put this one behind. It is the same answer in a more beautiful way. So I like to do that, put the answer like that. So that's all for this first miscellaneous exercise. I'm going to do the second and last one. Last miscellaneous exercise. Okay, for the second and last miscellaneous exercise, we have x squared plus 2 on x squared minus 4. Okay. On x squared minus 4, to find a partial fraction. What do we do? That the numerator's degree is 2. The denominator's degree is also 2. It is not less. It is the same. If it is the same, you don't really need to do the long division method. You can bypass it. If it is the same, I'll give you, if you do the long division method, you have a correct answer. It is very good to do it. If it is the same, you can still do the long division method and you have the answer correct. So, what I would like to do is put this one down here up. So this will be equal to x squared minus 4. But what is up on the numerator is x squared plus 2. What will I add here to make it to be the same like this? I have already x squared minus 4. If I add 6, it is the same like saying, check it out, x squared minus 4 plus 6. Minus 4 plus 6 is the same like 2. So you copy this first up, then you know what you have to adjust so that it comes back this 2. You see, so x squared minus 4 by x squared minus 4 divided by x squared. So that this should cancel this. You are seeing that x squared minus 4 and x squared minus 4 is the same. You can cancel if, check this out, this and this is the same as x squared minus 4 on x squared minus 4 plus 6 on x squared minus 4. The same. If you have a plus b on 2, the same like a on 2 plus b on 2. It's the same. So it is this rule that apply here to have this. So from here, you can see that these two can cancel. Will be equal to 1 plus 6 on this is 1 plus 6 on x squared minus 4. That is the answer. On the previous exercise, we have an x. X items per answer. Okay. So here, we have 1 plus 6 on x squared minus 4. If you do the long division method, you are going to come out with this same answer. As a matter of fact, let's do it. If we do the long division method, we have x squared minus 4 x squared plus 2. Let's do it and see. What do I need to multiply here so that we'll cancel this? I have 1. 1 with 1 times minus 4. Minus 4. So how this one, how did I do? I just looked at this one and this one. I divided them. X squared divided by x squared equals to 1. Divide this one by this one, not this one by this one. Here you have x cubed and x squared. You divide this one by this one. So you do x cubed over x squared. So in this case, you have x squared. 2 minus minus 4. I just said it was plus. You can see. So the power here is already smaller than this one, so we stop there. When we stop there, we're going to have 6. We're going to have 1 as the answer, 1 whole number plus 6 divided by x squared minus 4. Are you seeing that is the same? Just exactly the same. Just that we did it here without going through the stress of the long division method. You can do the same if this one is bigger. If this one is bigger, you do long division only. You cannot do this. You cannot do this if this one is bigger. Alright. So when you continue here, you have the remarkable identity. Here you have a difference of 2 squares. You can represent this one as partial fractions. Representing 6 on x squared minus 4 as partial fractions, you have 6. It is the same like 6 on x plus 2. Yeah, I explained this before. That no, just write it. I'll explain that x squared minus a squared is the same like x plus a, x minus a. X squared minus a squared is the same like x plus a, x minus a. In this case, you have x squared minus a squared is 4. X plus 2. 4 is 2 squared, right? So I have x plus 2, x minus 2. That is just what I have. That's just what I've done here. So, to find this in partial fraction, I'll copy it back here. I'll have 6 on x plus 2, x minus 2. To find this in partial fraction, I can see that it is a linear factor as denominator. I have a on x plus 2 plus b on x minus 2. I use my cover-up method. This will give, when using my cover-up method, if I equate this to 0, I have x plus 2 equals to 0. So when I have my x as minus 2, I cover this x plus 2 here, cover-up method, I cover it here, and I bring the x. And my x is minus 2, I'll have a is equals to 6 all over, I replace x by minus 2. Minus 2 minus 2 is what? Minus 4. 6 divided by minus 4, and I can see that it can be simplified. 3 divided by minus 2. That's my a. I do same for b. For b, I have, what is under b? X minus 2. So I equate it to 0. X minus 3 equals to 0. X will be equal to 2. So my x is equal to 2. What do I have my b equals to, I covered, so I have 2 here. 2 minus 2 will be 0. 0, you cannot divide something by 0, so I cover up this. And I put my 6 divided by, covering this, I will consider just this. 2 plus 2 is 4. So my value of a is 3 on minus 2, or minus 3 on 2. It's the same you should put there, minus up or down. And b is 3 on 2. So when I have that, I represent this in partial fraction. So 6 on x plus 2 into x minus 2 is equal to a, my a is minus 3 on 2. Minus 3 on 2 into x plus 2. Plus b is 3 on 2. 3 into 2x minus 2. That's my b. That's my a. That's my b. If you want, you put this one before, still a very correct answer. But actually, this is not your final answer because you have to add this one. So your final answer will be is x squared plus 2 on x squared minus 4 is equal to 1. This one, don't forget it. 1 plus, now this one here, put it already in partial fraction, it becomes this. I'll choose to put this one first to remove the minus, or I can still put this one, well, whatever. I put this minus 3 on 2 x plus. Oh, my answer for A was minus 3 on 2. Since A is minus 3 on 2, I put the fraction. So the upper part of the fraction stays up, the lower part stays down. So I put it up and down like this. Same for this one. Plus 3 on 2 into x minus 2. 2 into x minus 2. I put my 3 up since it is 3 up, and I put my 2 down. So it is 2 down. And I leave my answer like this. So that is all.